Here's a puzzle that hides in plain sight. A block slides across a floor, flies off the top of a staircase, and lands exactly at the far edge of the third step. From that single landing spot, we can work backward and recover how far the block slid. Let's see how. Start with the full picture. A block of mass m begins with speed v0 sliding along a horizontal floor. Kinetic friction with coefficient mu sub k slows it steadily over a distance s. At the edge, it launches horizontally off the top of a staircase and becomes a projectile. It falls past 3 steps, each with a rise h and a run d, striking the far end of the third stair. That landing point sits 3d across and 3h below the launch. Our unknown is as the slide distance. The strategy splits the motion into 2 stages. First the friction slide, then the free fall. And we solve them in reverse. The landing fixes the launch speed, and the launch speed reveals how far the block traveled on the floor. Stage 1 is the slide across the floor. Set up coordinates with the positive x direction pointing along the motion and the positive y direction pointing up. 3 forces act on the block. Gravity pulls straight down, negative m times g in the y direction. The normal force m pushes up, and kinetic friction points backward, opposing the motion as negative f sub k in the x direction. Now apply Newton's second law one component at a time. In the x direction, negative f sub k equals m times a sub x. In the y direction, n minus m times g equals m times a sub y. The block never leaves the floor, so its vertical acceleration a sub y is 0. And the second equation gives n equals m times g. Kinetic friction is mu sub k times n, which is mu sub k times m times g. Substitute that into the x equation and cancel the mass. The horizontal acceleration is a sub s equals negative mu sub k times g. The acceleration is constant, so use the kinematic equations. The horizontal velocity is v sub s of t equals v0 plus a sub s times t. The horizontal position is x of t equals v0 times t plus 1/2 a sub x times t squared. Starting from the origin, call t1 the instant the block reaches the edge, where its position is s and its speed has dropped to v sub x1. The launch speed, substitute a sub x equals negative mu sub k times g. The position equation becomes s equals v naught times t1 minus 1/2 mu sub k times g times t1 squared. Now solve the velocity equation for that time. t1 equals v0 minus v sub x1 all over mu sub k times g. Substitute this time back into the position equation. After the algebra, the difference of squares factors, and the result is clean. S equals v0 squared minus v sub x1 squared all over 2 mu sub k times g. This is the timeless kinematic relation, velocity squared against distance. But we still don't know the launch speed v sub x1. That comes from the fall. Stage 2 is the free fall of the staircase. Reset the clock and place the origin at the top of the stairs, where the block launches. Now there is no floor beneath it, so there is no friction and no horizontal force. The horizontal acceleration is 0, and the vertical acceleration is negative g. The block launches horizontally, so its initial vertical velocity is 0. And its initial horizontal velocity is the launch speed v sub x1. Let t2 be the instant it strikes the third stair. Horizontally, it has traveled 3d, so 3d equals v sub x1 times t2. Vertically, it has dropped 3h, so negative 3h equals negative 1/2 g times t2 squared. Solve the horizontal equation for the time. t2 equals 3d over v sub x1. Substitute that into the vertical equation and you get 3h equals 1/2 g times 9d squared over v sub x1 squared. Solve for the launch speed squared. v sub x1 squared equals 3gd squared over 2h. The geometry of the landing has pinned down the launch speed. Now assemble the answer. Stage 1 gave the slide distance in terms of the launch speed, s equals v0 squared minus v sub x1 squared all over 2 mu sub k times g. Stage 2 gave the launch speed squared, 3gd squared over 2h. Substitute the second result into the first. The slide distance is s equals v0 squared minus 3gd squared over 2h, all divided by 2 mu sub k times g. Every symbol here is a given quantity. The starting speed v0, the friction coefficient mu sub k, gravity g, and the step dimensions h and d. And notice the answer makes physical sense. A larger starting speed means a longer slide. More friction, a bigger mu sub k, means a shorter slide. And the mass has completely cancelled out. On the same floor, a heavy block and a light block slide exactly the same distance. Step back and see the pattern. A hard problem became easy once we split it into two familiar stages, friction slowing a slide and the gravity shaping a fall, then link them through the one quantity they share, the launch speed. Working backward from where the block landed, the staircase geometry set that speed, and the speed unlocked the slide. Split, solve, and connect. That's the whole method. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.